Matt is moving in a circle. In order for him to be moving in a circle, there must be a force constantly pushing him toward the center of the circle, called the centripetal force. In this case, the centripetal force comes from the tension in the ropes, which are also supporting Matt's weight. The amount of time it takes for Matt to make one full revolution is called the period. We can use this information to calculate values that we don't know, like the length of this rope. Here's a diagram that shows the forces acting on Matt when he moves in a circle. To simplify, we'll treat the system as if there's only one rope. The forces are balanced in the vertical direction, so the force of tension, Ft, times the cosine of the angle that the rope makes with the vertical is equal to Matt's weight. And Ft times sine theta is equal to the centripetal force. Before we could find the length of the rope, we need to measure the period, which, as seen here, is about 5.5 seconds. We also need to measure the radius of the circle, about 68 inches, or 1.7 meters. Using these equations, where v is Matt's linear speed, t is the period, m is Matt's mass, and r is the radius of the circle, we can find theta, and then use theta to find the length of the rope. These are the values that we found. To check if our calculations were accurate, we attached a long string to a softball and threw it over the branch where the swing is tied. Then we marked the point on the string where the ball reaches the bottom of the rope. We took it down and measured it with a tape measure. Our calculation of 25.5 feet proved to be very accurate.
Air resistance, or drag, is a force that acts on objects moving through air. The drag force opposes the direction of motion and increases as the object's velocity increases. Terminal velocity occurs when the drag force balances the force of gravity and it causes the object to move at constant speed. The coffee filter has very little mass, so it reaches terminal velocity quickly while the basketball continues to accelerate.
Damn it. Yes.
An object's center of mass, or center of gravity, is the point which can be used to describe the system's response to external forces and torques. All of the object's mass can be considered to be concentrated at the center of mass. An object will fall over when the center of mass is no longer above its base. A unicycle has a very small base, which makes it hard to balance. To compensate, I could move the wheel to keep it under the center of mass. I wouldn't be able to balance if I wasn't moving. A smaller unicycle lowers the center of mass, making it more stable. Despite this, I think it's the hardest unicycle to ride. When riding a tall, known as giraffe unicycle, a small displacement from a vertical position causes a large displacement of the center of mass relative to the base. So there's a smaller margin for error while riding.
Torque is a force that rotates an object about an axis. In this case, the axis of rotation is the back wheels of the skateboard. When the skateboard stops, the ball leaves its circular path with a velocity tangent to the circle.
Angular momentum is defined as the product of moment of inertia and angular velocity. In this case, we can simplify by assuming the mass of the cable that holds the baseball is negligible, and instead use this equation, where r is the radius of the circle and v is the velocity of the ball. When Matt hits the ball, it begins to move in a circle, but the radius of the circle decreases as the cable wraps around the pole. Notice how the ball moves faster when the radius becomes smaller. Angular momentum is always conserved, so the total amount of angular momentum in the system remains constant. If the radius decreases and the mass remains the same, the velocity of the ball must increase. A projectile is an object projected into space by the exertion of a force. Projectiles, primarily basketballs as you'll see in this video, are affected by a few forces before and during their flight. In general, The shooter accelerates the ball from rest to a certain initial velocity to allow the ball to land in the hoop. While in flight, the ball is acted on by gravity and a drag force. We cannot ignore air resistance because this is Physics C. To help us with these projectile motion experiments, we had to hire some experts. Yeah!